man, hip-hop is liked most, according to this data.
According to this data.
Right.
All right. And then now, let's look now. So hip-hop is liked most. All right, fine. Then we see that dancehall
comes next.
So dancehall would be more than reggae, more than R&B.
But less than hip-hop.
Less than hip-hop. Can we say anything else? Because Sambo and Sage still want to gather some more information.
Well, we confirm that they used 40 students because hip-hop is 20, R&B looks like 6 there, and dancehall is 10, and reggae is 4. So if you were to add 4 and 10, that's 14, 14 and 6, that's 20, and 20 and 20, that's 40. So the data tells us some things. It tells us that all the members of the class were surveyed.
Yes, that's true. So this would be a good data because everyone responded.
Yes.
All right. Or more than 50%.
There you go. 100% respond in this case.
Yes, yes.
All right.
But was Sage correct in her assumption?
No.
Boy, I'm sorry for Sage.
So you see, assumptions are not necessary when you're dealing with statistics. Use the evidence that you have. Look at the statistical data, then you make inferences and conclusion. Assumptions don't count here.
Not at all. And lastly, there's another grade 11 class, 11-1. Can Sage make an assumption on the favorite genre for both
What I tell you about this assumption thing?
Well, she has the data for her class, so what you talking about?
There you go, it's for her class. So she cannot make any assumption for another class.
But hold on.
This data set is only for the class that she has surveyed.
But it's the same grade 11 stream.
But it's different kids. I can't take your data from your family and say, okay, if your neighbor are gonna like the same thing that you like. So, no, I can't.
All right, you have a point.
So I can't use this set of data and throw it on another class.
All right, you have a point.
Assumptions are not needed in statistics. We will only look at the statistical data given. That's something that we need to remember. Pay attention to the data set that you are working with.
All right.
Yes.
Let's take a look now at Mrs. Baker's class.
Right.
Mrs. Baker gave her grade 8 class a mathematics test in November and recorded the scores obtained by students to the nearest percentage in the table below, and we're seeing our table.
Right.
She wants to know from the table given which of the following statements is most likely to be true in order to make adjustments for the end of term test they will do in December. So we're looking at our table.
So which is most likely to be true?
Most likely. So A, the modal class is 41, between the class 41 to 60. B, more than half the number of students scored over 50% on the test.
All right.
So remember now, we're using our table. And we need to know, draw some conclusions, draw inferences from our table.
And see which one is it, A or B.
Nice. And
I'm going to start with B
likely
to see if, you know, I like to work like that sometimes. So more than half the number of students scored over 50% on the test. Okay, so 50% would start in the class 41 to 60.
That's our third class.
Right. No, my issue is why I can't tell you yes or no. Although there are 8 students in that class, I really don't know what their scores were. They could have gotten 42. All of them could have gotten 42 or 43.
But 50% is within the class.
Yeah, but I don't know how many of them got 50, so I can't tell you. How many out of that class got over 50%. So you know what happened? I'm going to choose B. Let me look at A and C.
So for B, then you're saying you can't choose, you can't say B. So you can't say more than half the number of students scored over 50% on the test.
No, because that class, there's no conclusive evidence for that class. You know, I can't, because everyone could have gotten below 50 and they could all have gotten above 50, but I don't know. I would have to look at individual scores. I'd have to bring out the raw data.
All right, and for A now, so you're correct for that one, you know. You're correct for that one, but for A now, the modal class is 41 to 60.
All right, no.
Now, we're still looking at the third class?
Modal class. So when you talk about modal class, you're talking about this class would have the highest frequency.
Which is correct.
Which is 8. So yes, so A is correct.
But hold on, man. Modal class? I am sure I heard the word or the term modal class and modal score. They sound very similar.
They have something similar. There's mode in there. but they're two different values.
Oh, they spell differently, score and class.
There you go. Well, you think? Score, class? Right. So the modal class has to do with the class with the highest frequency, while the modal score is the actual value, that single value that appears most frequent within the set of data. Now, the modal score, looking at this particular representation, I can't determine it just by looking at it.
Even though it has the most frequency?
No. Yes, but guess what happened? As I said before, what if everyone in that class got a different score? So I have 8 scores in that class, but they all are different scores. That means the modal score is not in that class. It could mean that, let us look at the second class, the 21 to 40. What if all 5 of those persons got the same 40?
Which means that would have been our modal score.
That would have been our modal score.
Oh.
But it is not a part of the modal class because the frequency is less.
Modal score,
Modal class. So let us just tie that up. The modal class is the class with the highest frequency.
Yes.
Right? While the modal score is the actual score, the actual data that appears most within the set of data.
I get it.
Okay.
I understand.
All right.
Clearer now. Very much clearer. All right, let's take a look at, remember we're still on statistical diagrams and we're still looking at statistics.
And here we go with another one.
Still making inferences from our raw data.
And no
tables,
assumptions.
charts, all these we're doing. So let's look here. So Lee and her friend Cami are members of the Girls Scout. They are selling cookies but realize that some days it seems like they are doing well, but some days it's not so well. Cami, being analytical, decided to record cookies sold daily and represent it on a suitable graph. What do you think they can gather from the data?
Well, I like this line graph because one, it's very simple and I can pretty much see that Friday is a good day. Friday cookies sell. I can just look at it and see because I would have seen the number of cookies on my, as you had pointed out, my vertical axis,
yes.
which is my y-axis there. And on my horizontal axis, my x-axis, I have the days of the week. So I'm selling cookies Monday, Tuesday, Wednesday, Thursday, Friday. Friday is the highest point. So I know that Friday, I want to sell cookies on a Friday.
I would sell cookies on a Friday because school finish on a Friday,
Well, that too.
So every money that you save during that week, I'm going to spend it on cookies.
I'm not selling no cookie on a Monday.
Why not a Monday, man?
Monday, nothing much is going on for Monday. According to this data, Monday is the worst day.
Monday is the worst days?
Yes,
Let me see. Oh, Monday is how many? 20 cookies?
20 cookies is sold.
All right, 20 cookies on a Monday. Let's go to a Tuesday.
30.
Approximately 33. Yeah, 30. All right, so Tuesday is better than Monday.
Good. Yeah, I can start on a Tuesday.
But still not good like Friday.
No, Wednesday good too.
Wednesday, yes. Look there, you don't see the trend,
Wednesday's
the pattern
45
taking place.
cookies. Wednesdays is a good day.
Wednesday, so
Thursday I can't stay with. Me not need to sell cookie on a Thursday.
you don't, but Thursday is more than Monday.
Yes, it is. But so if I was to choose 3 days to sell cookie, I would go with Tuesday, Wednesday, Friday. If I was to choose one day, it would be Friday.
But guess what? No. So Monday, Tuesday, Friday. Those are the days you would sell.
If it's 3 days, I'm selling cookies.
3 days. But in looking at this line graph too, I think this was a good way for Cami to have represented
I think so too. It's easily understood.
It is. And remember, she said that she knows that they were doing well some days, and some days they weren't doing well.
So guess what? Patterns occurring so that they know. So when you have a line graph, you can see the patterns that occur within the line graph. So she can pretty much see that if she's selling cookie every week, there are certain days that she should really and truly carry more cookie.
And she can also see here from the line graph that, hey, there's an increase from Monday to Wednesday.
Therefore.
And then there's a decrease.
I wonder what would have caused the decrease on Thursday though. You get enough cookie Wednesday, seeing about a one on Thursday?
Maybe, maybe. It could be. We're not sure.
Exactly. So that's another set of statistical data we need to collect.
We can't even assume
no
right
assumption here. No assumption.
Not at all. All right. So we're all right with Cami and we're all right with Lee because they know now, all right, These are what is happening. We're looking at the patterns. We're looking at the trend right here. Which days are the best days then to sell cookies on? Which days are not so good? So they're able now to pinpoint and to make a decision, as we would have said earlier. What are the best days to sell cookies?
So pretty much.
What are the best days not to sell
There
cookies?
you go.
So we have best days to sell and best days not to sell.
I'll tell you. So we can pretty much say that, you know, when we use a line graph, it helps us to identify patterns easily. We also are able to see trends much easier than if we were looking at a pie chart, right? So yes, some data set, a line graph is perfect.
Line graphs, all right. But for those who would have missed the first section,
just joining us.
So what we have been looking at, we're just recapping what we would have been doing from we started to now. So we're looking at the importance of statistics to mathematically describe or depict finding. We're also trying to draw conclusions from findings. And we looked at some examples of statistical diagrams thus far. We looked at a pie chart, we looked at bar graph, we looked at line graph as well.
And the table.
We looked, oh yes, we looked at
that table with the class and the modal class and the modal score. Yes, we did.
We looked at the table, we looked at the table. So let's see if they have been following, because some may have started after
we looked at
some stuff. So guess what?
Let's look at another scenario.
So Asher and his friends want to have a movie night with their classmates, but they don't know the type of movie to play, since each person has a favorite type. Alistair told Asher he believes they should gather the data from their friends and make a decision at that time.
That makes sense. I like Asher's style. Yeah, man, you have to, it's Alistair. It's Alistair.
Oh, it's
Alistair
not
told
Asher.
Asher. Right, so Alistair is on the right track. Let's not assume anything. Let's gather some information.
And in gathering the data too, it's so good that with gathering this data, they're not only using what they like, Alistair and Asher, but they're looking at their classmates.
Exactly. So
because it's going to benefit their classmates.
Exactly. So they're trying to choose the best fit type of movie to watch.
The favorite type of movie to watch. So let's take a look here.
So they collected their data.
Collected the data.
And this is what? Bar chart. So they have presented the data on a bar chart. So let's see what movies they have in mind. So they have comedy, action, romantic, drama, and sci-fi. Now, according to this, what would be the best choice?
Boy, I would say romance, you know, because romance is way up there. So I would say romance. I wouldn't even look on drama.
Drama not going to play?
No, sir, drama not going anywhere. But I think Alistair wants to know how many friends they interviewed in order to make a decision. But why do you think he want to make this decision now?
Well, maybe he's looking at other things, because if he's looking at the number of persons that they would have interviewed, he probably would know what space to use. If he's at school, what room to decide to use.
Can't be at school right now.
Well, that is true. So if he is using a personal space, or he wants to make sure he is socially distancing, he may need to decide what size room he's going to use. And if he's catering to them with popcorns or stuff, he needs to know the number of persons that are coming. So let us see what we could use to help him do that.
So this information is important.
Oh, yes, it is.
Yeah, man, it's important.
So according to the, you have four shows comedy. We had 5 for action, so that's 9 already. 6 for romance.
That's 15.
There you go. And 1 for drama. And 4 for sci-fi.
20.
So 20 persons. So he needs a space that can hold 20 persons with proper social distancing.
And enough popcorn.
And enough popcorn. Each of them have to get their own, because we're not sharing. There's no sharing.
Even if they don't get their own, we can maybe share it,
well,
you know.
20
so we'll not share it. Yes, 20
containers.
But 20, including both of them, man.
Oh, yeah.
Alistair, why
so
are you leaving out Alistair and Asher, 22, man?
Right.
Because they were not a part of this data that was collected.
No, because they would already know what they liked.
Yes, nice.
So what we're saying, when you have a data set or representation of statistical evidence, there are several things you can get from it. So although they just were looking at initially the type of movie that they wanted to watch, from the data that they collected, they could also determine how many persons would partake in this movie watching. All right.
They could. I think they have another question. How can Asher and Alistair know the type of movie most friends like? We already know. We already talked about
we
that.
tell them already. So.
Romance, don't it?
Right.
And let's see now. What if Asher could not find a romantic movie? What would be the next favorite type of movie?
Well, according to the data, we look at
That's what I was going to say,
yes.
because what if Asher no want to say, boy,
You want to watch drama?
Drama.
No.
What a pricky that would be.
Them would have upset.
Very upset.
Right. So they would have to look at the next highest data set, and that would have been
Sci-fi.
No, miss.
Of course, sci-fi and comedy tie.
Yes,
the tie for 4.
But action win them. Action
I know,
get 5.
but still, look on comedy and look at sci-fi.
All right.
Comedy is 4, sci-fi is 4. That
Good
means
observation.
8 of them vote for comedy and sci-fi.
So we're going to get a comedy sci-fi movie.
I'm sure we can find one.
Well, if it's a comedy sci-fi, sure, but that's not how we read the data, though. We read the next set of data. So we have 6 persons who would have chosen romance. The next data set, which is closest to it, would be 5. So it would be an action movie, miss. However,
Fine. You
if
win.
it's comedy or sci-fi, either one can play.
Fine, you
Okay.
won. So we saw that there was some tying coming in here too, that hey, some chose comedy, the same number chose comedy, chose sci-fi.
Yes.
Doesn't mean it's
It
it's
doesn't
not
mean
the
that
same, you know.
you can combine it to give you a higher data
Well,
set.
maybe we could combine romance and action.
Well, yes, you could. It would be 11, don't it?
Yes.
No,
it
we're
would
not
be.
going to do that. We're looking at one particular type of movie. So we would have to look at the data set by itself.
All right, so it's
Great.
romance. All right,
All right.
fine. And our final scenario
There you go.
for session today, you know. During an election for student council president, Mark was the clear favorite to win. Anthony pulled out of the election due to personal reasons. Mark lost the election to Simone. He blamed his loss on the fact that Anthony pulled out of the election. Could this be true? Provide reasons to support your answer. Boy,
All
me no blame Mark, you know, me no blame Mark.
So you believe that Mark has justifiable reason to say that is because of Anthony pullout? Well, guess what happened? With this information as is, it's not sufficient. It's just pure assumptions. So once again, without data, without sufficient statistical data, no conclusion can be made, no inference should be made. We really should get data on this because we don't know why Mark was not victorious here.
Maybe they voted for Simone.
Right, because
they like Simone more than Mark.
There you go. So we can't assume anything.
We can't. And guys, that's it for today's lesson. We hope you understood and learned. And remember, math is about effort. So put in all that you can.
We take a break for some house cleaning, after which class time continues with CSEC Spanish.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
It's here. Interactive classes for all ages on the School Time channel on onespotmedia.com. With a combination of live Zoom classes and recorded class time, Schools Not Out lessons, and numerous educational content, we've created a comprehensive 24-hour channel dedicated exclusively to educating our nation's youth. Early childhood through to primary, secondary and tertiary, it's one stop on one spot for education 24 hours. Brought to you by the Ministry of Education, Youth and Information in association with Television Jamaica Limited.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Welcome back. I'm Yaliet de la Cruz Paul Morgan, and this is
Kevon Edwards.
And we are here to guide you through the world's fourth most spoken language. This is CSEC Español. Buenos días, profesor Kevon.
Buenos días, profesora Yaliet.
¿Cómo está usted?
Estoy muy bien, gracias. ¿Y usted?
Muy bien, gracias. Bueno, profesor Kevon, ¿qué van a aprender los estudiantes en la clase de hoy?
Vamos a aprender escuela y carrera.
Vaya, es un tema muy interesante.
Sí.
Ahora vamos a decirle a los estudiantes cuál es el tema específico de la clase de hoy. Van a aprender qué actividades escolares solías hacer antes de la pandemia. ¿Qué actividades escolares solías hacer antes de la pandemia?
Entonces, profesora, students, do you remember from the previous lesson what we looked at in Spanish? Muy bien. So we'll be looking at what school activities you did before the pandemic.
Ok, perfecto.
Now, students, at the end of this lesson, you will be able to talk about actions you used to do before a specific period using the imperfect tense. Ask and answer questions about actions you used to do. Make comparisons between what you used to do and what you do now.
Muy bien. And in the case of grammar in context, you will use the imperfect tense while giving opinions and stating points of view. Ahora van a observar un video y dinos de qué trata el video. ¿Escucharon? Van a observar un video y dinos de qué trata el video. What
Now,
they are
students,
going to do?
you are going to observe a video and you are going to tell us what you think the video is about.
Muy bien. ¿Están listos? Are you ready? Let us observe that video.
Gracias a todos los televidentes. Bienvenidos a la estación de televisión Sobreviviendo la Pandemia. Hoy, ahora, en este momento, vamos a entrevistar a algunos estudiantes para saber qué hacían antes del coronavirus, antes de la pandemia. Buenos días, ¿cómo estás?
Buenos días, muy bien, gracias. ¿Y usted?
Muy bien, gracias. ¿Cómo te llamas y cuál es el nombre de tu escuela?
Me llamo Shari Oliver y voy a la Escuela Convent of Mercy Academy Alpha.
Perfecto. Dime, ¿qué actividades escolares solías hacer antes de la pandemia?
Pues, antes de la pandemia, le escribía notas en mi libretas mientras la maestra atendía a mis amigas.
Buenos días, ¿cómo estás?
Buenos días, bien, gracias. ¿Y usted?
Yo estoy excelente, gracias. ¿Cómo te llamas? ¿Y a qué escuela perteneces?
Me llamo Trista Harris y mi escuela es Convent of Mercy Academy Alpha.
Perfecto. Dime, ¿qué actividades escolares solías hacer antes de la pandemia?
Bueno, antes del coronavirus yo corría en la pista de la escuela durante mis clases de educación física.
Buenos días. ¿Cómo estás?
Buenos días. Muy bien, gracias. ¿Y usted?
Estoy de maravilla. Muchas gracias. ¿Cuál es tu nombre y a qué escuela asistes?
Me llamo Dijon Wright y mi escuela es Kingston College.
Super, es un placer. Dime, ¿qué solías hacer en tu escuela antes de la pandemia?
Bueno, antes de la pandemia, yo leía libros interesantes en la biblioteca de la escuela en las mañanas.
Muy bien, ahora que observaron el video, vamos a ver. Yo creo, profesor Kevon, that the student need to observe the video one more time.
Sí, estoy de acuerdo, profesora.
Y en este caso van a decirnos qué dijeron los estudiantes. ¿Qué dijeron los estudiantes? So you are going to observe the video and are going to tell us what did they say, ¿ok?
Entonces, vamos a ver el video una vez más.
Ok.
Buenos días a todos los televidentes. Bienvenidos a la estación de televisión Sobreviviendo la Pandemia. Hoy, ahora, en este momento, vamos a entrevistar a algunos estudiantes para saber qué hacían antes del coronavirus, antes de la pandemia. Buenos días, ¿cómo estás?
Buenos días, muy bien, gracias. ¿Y usted?
Muy bien, gracias. ¿Cómo te llamas y cuál es el nombre de tu escuela?
Me llamo Shari Oliver y voy a la escuela Convent of Mercy Academy Alpha.
Perfecto. Dime, ¿qué actividades escolares solías hacer antes de la pandemia?
Pues, antes de la pandemia, le escribía notas en mi libretas mientras la maestra atendía a mis amigas.
Buenos días, ¿cómo estás?
Buenos días, bien, gracias. ¿Y usted?
Yo estoy excelente, gracias. ¿Cómo te llamas y a qué escuela perteneces?
Me llamo Trista Harris y mi escuela es Convent of Mercy Academy Alpha.
Perfecto. Dime, ¿qué actividades escolares solías hacer antes de la pandemia?
Bueno, antes del coronavirus yo corría en la pista de la escuela durante mis clases de educación física.
Buenos días. ¿Cómo estás?
Buenos días. Muy bien, gracias. ¿Y usted?
Estoy de maravilla. Muchas gracias. ¿Cuál es tu nombre y a qué escuela asistes?
Me llamo Dijon Wright y mi escuela es Kingston College.
Super, es un placer. Dime, ¿qué solías hacer en tu escuela antes de la pandemia?
Bueno, antes de la pandemia, yo leía libros interesantes en la biblioteca de la escuela en las mañanas.
Muy bien, entonces, ¿estamos listos? Profesor Kevon, ¿ha estado recibiendo algunos mensajes de los estudiantes?
Sí.
Ok.
Hay la respuesta de
Vamos a ver algunas
María.
respuestas.
Vamos a ver. Yo escribía notas en mi libreta mientras la maestra atendía a mis amigas.
Sí, pero ahora no puede porque las clases son por Zoom. A ver, señor Quebón, aquí tengo otro mensaje que dice: yo corría en la pista de la escuela durante mis clases de educación física. Vamos a escuchar otra vez. Yo corría en la pista de la escuela durante mis clases de educación física. Ahora.
Entonces, pero ahora no pueden correr en la pista porque las clases de educación física son en línea.
Sí, todo es muy diferente. Aquí tengo otra respuesta. Y dice: yo leía libros interesantes en la biblioteca de la escuela en las mañanas. Vamos a escuchar otra vez. Yo leía libros interesantes en la biblioteca de la escuela en las mañanas. Muy bien.
Ahora lee libros en su casa porque no puede ir a la biblioteca de la escuela. Una vez más, estudiantes, ahora lee libros en su casa porque no puede ir a la biblioteca de la escuela.
Sí, todo es muy diferente.
Sí, muy diferente, profesora. Entonces, estudiantes, what were some of the activities that you used to do at school before the pandemic?
Sí, estudiantes, ¿qué solías hacer en la escuela antes de la pandemia? ¿Qué solías hacer tú en la escuela antes de la pandemia? Think about it. Y profesor Quebón, ¿qué solía hacer usted en la escuela antes de la pandemia? What did you used to do at school before the pandemic?
Entonces, estudiantes, vamos a ver en este momento ahora. Antes, yo comía con mis amigos todos los días en la cafetería de la escuela. Una vez más. Antes yo comía con mis amigos todos los días en la cafetería de la escuela. Ahora como en mi casa.
Sí, y en mi caso, antes yo distribuía los libros a mis estudiantes en el aula. Vamos a escuchar. Yo distribuía los libros a mis estudiantes en el aula. Pero ahora les envío correos electrónicos. Y usted, profesor Quebón, ¿qué otra actividad hacía antes de la pandemia?
Antes, yo oía a mis estudiantes reírse durante mis clases. Pero ahora cierro sus micrófonos en Zoom.
Vaya, hay otra actividad que yo solía hacer.
Sí, vamos a ver, profesora.
Pues antes nosotros nos reuníamos frente a frente en la reunión de departamento. Antes nosotros nos reuníamos frente a frente en la reunión de departamento, pero ahora tenemos reunión vía Zoom. Todo es diferente, incluso para los profesores. Entonces, estudiantes, ahora llegamos a una parte muy divertida de nuestra clase y vamos a cantar. Entonces, primero van a escuchar y después van a cantar con nosotros.
Entonces, estudiantes, at this time we are going to do a very fun activity and I want for you to join us and sing with us. Vamos a cantar, let's sing.
Let us listen.
Vamos a escuchar.
Estudiantes, este es el tiempo del imperfecto. Sígueme y repite conmigo. Ia, ias, ia, íamos, ian. Ahora, repite otra vez. Ia, ias, ia, íamos, ian. Perfecto. Repetimos otra vez. Ia, ias, Ia. Íamos, ian. Muy bien, estudiantes. Ahora van a escuchar otra vez. We are going to do it this time, but you are going to sing with us, okay? So listen and repeat after me. Let us do it again. And we start over. Estudiantes, este es el tiempo del imperfecto. Sígueme y repite conmigo. Ia, ias, ia. Íamos, ian. Ahora, repite otra vez. Ia, ias, ia. Íamos, ian. Perfecto. Repetimos. Otra vez. Ia, ias, ia. Íamos, ia. Muy bien, estudiantes. Un aplauso. And we finished with this segment. This was great. I really love it. I hope you love it as well. So, vamos a continuar.
Entonces, estudiantes, en este momento vamos a practicar. ¿Estamos listos? Muy bien. Ella asistía a la escuela todos los días. Repitan, por favor, estudiantes. Ella asistía a la escuela todos los días.
Ahora, escuchen y repitan. Nosotros aprendíamos palabras nuevas en la clase de español. Nosotros aprendíamos palabras nuevas en la clase de español. Muy bien, ¿continuamos?
Sí, vamos a continuar. Tú decías las tablas de multiplicar en el aula. Repitan, estudiantes. Tú decías las tablas de multiplicar en el aula.
Muy bien.
Continuamos.
Él compartía su almuerzo con sus amigos. Vamos a repetir. Él compartía su almuerzo con sus amigos. Muy bien, continuamos.
Sí, la señora Reed escribía mucho en la pizarra. Una vez más, estudiantes. La señora Reed escribía mucho en la pizarra. Muy bien.
Perfecto.
Now, students, we are going to look at some tips for Section A of CSEC Spanish Paper 1. Practice online using audio exercises. Muy importante. Listen to music. Music has the great aspects of flavor and rhythm and enhances memory. Watch movies in the target language, español, por supuesto. Join a language exchange group. Listen to the words and try to picture what it is about, okay?
Muy importante. Y continuamos. Also, listen to the words and try to picture what they are about. Listen to the words and try to picture what they are about. Also, listen to the action being done and by whom. Look at the images and relate them to the vocabulary or words you know. This is really important. Look at the images and relate them to the vocabulary or words you know. Also, try to focus on the general idea of the audio. Try to focus on the general idea of the audio. And finally, don't try to get every detail that is mentioned. This is really important. Don't try to translate everything. Just try to get the general idea of the audio. So, vamos a continuar.
Now, students, we're going to show you an example of Section A of the CSEC Spanish Paper 1. But first, let us go through the instructions. For each question in this section, you will hear a single sentence. Choose from the 4 pictures in your test booklet the one picture which shows what the sentence is. Then shade the corresponding space on the answer sheet. And we're going to do the instruction again for you, students. For each question in this section, you will hear a single sentence. Choose from the 4 pictures in your test booklet the one picture which shows what the sentence says. Then, shade the corresponding space on the answer sheet.
Muy bien. Ahora, for example, you hear, el muchacho comía en el restaurante. El muchacho comía en el restaurante. So it's important that you know that you are going to look, you have only 15 seconds. Tienes 15 segundos para mirar la imagen. So you are going to look at the image 15 seconds and then you will listen to the sentence and you have to choose, okay? So, for example, you hear, el muchacho comía en el restaurante. El muchacho comía en el restaurante. Okay, the time to stop.
See? So students, the correct answer is the 3rd picture. So you would shade the space with the letter C on the answer sheet. And students, it is very important that you listen to the key word or words in the sentence to give you an idea of what the sentence is saying. And of course, the images are there to guide you. Muy importante.
Entonces, vamos a comenzar. Tienen 15 segundos para observar la imagen.
So students, we are going to begin and you have 15 seconds to observe. Entonces, número 1. El hombre escribía una carta. Una vez más, el hombre escribía una carta. So look at the images.
Second, los niños comían en el comedor. Los niños comían en el comedor.
Número 3. La mujer discutía con la enfermera. La mujer discutía con la enfermera.
Número 4. Él oía música con sus audífonos. Él oía música con sus audífonos.
Número 5. Tú leías un libro en la cama. Tú leías un libro en la cama.
Número 6. Nosotros nos reuníamos en el parque. Nosotros nos reuníamos en el parque.
Número 7. Yo me reía muy alto. Yo me reía muy alto.
Número 8. Ellos conducían un carro. Ellos conducían un carro. No, ahora vamos a ver las oraciones.
Now let's see the sentences. Número 1. El hombre escribía una carta.
Los niños comían en el comedor.
La mujer discutía con la enfermera.
Él oía música con sus audífonos.
Número 5. Tú leías un libro en la cama.
Número 6. Nosotros nos reuníamos en el parque.
Número 7. Yo me reía muy alto.
Número 8. Ellos conducían el carro. Ahora vamos a... Estudiantes, ¿están listos? Are you ready? Well, esperamos que tengan todas las respuestas. So, let's now see the answers.
Vamos a ver las respuestas. Entonces, el hombre escribía una carta. La respuesta correcta es C. Okay? Now, students, why you chose C? What were the words you heard? Is it el hombre escribía? Muy bien.
Perfecto. Vamos a ver. For the second one, you're supposed to choose item A. La respuesta correcta es A. Los niños comían en el comedor. What keyword guide you to this answer? It was niños, comían, restaurante, comedor. Muy bien, excelente. Lo están haciendo muy bien. Vamos a continuar.
Sí, continuamos. La mujer discutía con la enfermera. La respuesta correcta es D. Now, students, what were the keywords that guide you to this response? Is it la enfermera? Discutía. Muy bien, estudiantes. Perfecto.
Vamos a ver. La próxima respuesta era item C, C. Él oía música con sus audífonos. Él oía música con sus audífonos. In this case, what keyword guide you to the answer? Música, oía, audífonos. Muy bien. Continuamos.
Sí, vamos a continuar. Tú leías un libro en la cama. La respuesta correcta es A. Now, students, what were the words that guide you to select A for your response? Is it cama? Is it libro? Or leías? Muy bien, estudiantes. Perfecto. Continuamos.
Y tenemos inciso B. La respuesta correcta es B. Nosotros nos reuníamos en el parque. En este caso, what keyword guide you to the correct answer? ¿Reuníamos? ¿Parque? Muy bien, excelente. Let us continue.
Vamos a continuar. Yo me reía muy alto. La respuesta correcta es D. Students, what were the keywords that guide you to choose D for your response? Is it reía? Muy alto? Excelente, estudiantes. Muy bien.
Entonces, la última respuesta fue A, item A. Ellos conducían el carro. What keyword guide you to this answer? It was conducían. It was carro. Muy bien. Excelente. Entonces terminamos. Vamos a continuar.
Sí, continuamos.
Estas son las respuestas generales. Okay, these are the general answers. ¿No? Vamos a ver. Vamos a hacer un ejercicio.
Sí.
Presten atención, estudiantes.
Now, students, answer the following situations in Spanish. Make sure you pay attention to how we talk about what we used to do in the past. So that's very important.
And remember, while you are answering, text us so we can get your answers and we discuss them at the end of the
Lesson.
situations.
Bueno.
All right?
Your mother is asking you to tell your younger sister what you used to do to be the first place runner at school. How do you express this in Spanish? B. Pablo y Mirtha are very lazy. They are telling their parents 3 things that they used to do at their grandmother's house during the summer. How do they express this in Spanish? C. Your cousin asks her friend what he used to do at school before the pandemic. What was the question she asked him? So students, think about the responses. Look at the situations.
Vamos a darle a los estudiantes un minuto para que contesten las preguntas, ¿ok? Vamos a darle un minuto.
So students, you have a minute to respond to the situations.
Ok, vamos a ver. Aquí tengo una respuesta de un estudiante para la situación número 1. Let's see. Your mother is asking you to tell your younger sister what you used to do to be the first place runner at school. How do you express this in Spanish? This student is saying, yo corría todos los días. Yo corría todos los días. Muy bien.
Excelente.
Vamos a ver.
B. Pablo and Mirtha are very lazy. They are telling their parents 3 things that they used to do at their grandmother's house during the summer. How do they express this in Spanish?
Ok, aquí tengo una respuesta. Talía dice, yo dormía todos los días. Yo dormía todos los días. What a lazy girl.
Sí.
Ok, she used to sleep every day. Ok,
C. Your cousin asks her friend what he used to do at school before the pandemic. What was the question she asked?
ok. Y Ricardo dice que la respuesta es, ¿qué solías hacer en la escuela antes de la pandemia? ¿Qué solías hacer en la escuela antes de la pandemia? Muy bien, muchas gracias.
Muy bien, estudiantes. Continuamos.
Entonces, estudiantes, ¿qué aprendiste hoy? ¿Qué aprendiste hoy? Vamos a ver.
Talk about actions you used to do before a specific period using the imperfect tense. Muy bien. Nosotros aprendíamos palabras nuevas en la clase de español.
También aprendiste, tú decías las tablas de multiplicar en el aula.
Él compartía su almuerzo con sus amigos.
La señora Reed escribía mucho en la pizarra. Also, you learn how to ask and answer questions about actions you used to do. And what was the question that you learned? In this case, ¿qué actividades escolares solías hacer antes de la pandemia? ¿Qué actividades escolares solías hacer antes de la pandemia? That was our focus question.
Sí.
Muy bien.
Make comparisons between what you used to do and what you do now. Yo comía pollo todos los días en la cafetería de la escuela. Ahora como en mi casa.
Okay, yes, you learn how to make a comparison between what you used to do and what you are doing now. Remember those sentences? Yo distribuía los libros a mis estudiantes en el aula. Ahora le envío correos electrónicos. Yo distribuía los libros a mis estudiantes en el aula. Ahora les envío correos electrónicos.
Yo oía a mis estudiantes reírse durante mis clases. Ahora cierro sus micrófonos en Zoom.
Y nosotros nos reuníamos frente a frente en la reunión de departamento. Ahora tenemos reunión vía Zoom. Nosotros nos reuníamos frente a frente en la reunión de departamento. Ahora tenemos reunión vía Zoom.
Entonces, tarea. Choose one of the following. Create a timeline with at least 3 activities you used to do at school and 3 school activities you do now during the pandemic using verbs ending with ER and IR.
Muy bien. And the second activity, you can choose the one that Mr. Kevondios read, or this one, create a song, jingle, poem, where you include different activities you and your friends used to do while at school before the pandemic. Use verbs ending ER and IR. This is very important. Remember that you have to use the verbs ending ER and IR.
Now, students, you can send your answers to Espanol en Jamaica Facebook page and Instagram, and also Spanglish Jamaica.
Y además, you can also get more content related to Spanish on the YouTube channel Simonette Hibbert. If you do not have access to the internet, we have a solution for you. You can also text us your answers or further questions to 876-875-6745. That's it, 876-875-6745.
Entonces, muchas gracias.
Y eso es todo por hoy.
Sí, es todo por hoy.
Okay, estudiantes, we've come to the end of the lesson, but do you know what is one of the best ways to remember Spanish? Oh, yes, if you speak it.
In that case, muchas gracias por compartir con nosotros hoy, estudiantes. Ahora es la clase de Cape Physics. Muchas gracias. Adiós.
Thank you for joining us for CSEC Spanish Cape Physics is after the break. Adiós.
Adiós. Chao.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
into Hello, and welcome back to Class Time Cape Physics. I'm Paul Bender, and today we'll be looking into alternating currents. Let's begin. When we think about the word current, we think of some sort of flow. Also, when we look at alternating current, we think of some kind of switching. And so today, as we go through our lesson, we will come to understand what alternating currents are all about. And we look at some of the characteristics and what you call parameters of alternating currents. All right, so this is our presentation for it. All right, at the end of this presentation, you should be able to do the following. You should be able to distinguish between AC means alternating current and DC means direct current. AC and the DC. Interpret graphs, because we can represent alternating currents. We can represent them graphically. And so we ought to be able to interpret the graphs of alternating currents. You also should be able to write down an equation for an AC, for an alternating current, because we can represent it also in equation form. If you can have graphs, we can have equations as well. And explain what is called RMS current or voltage. RMS means root mean squared current or voltage. This is a new term, and so we will spend a little time on it. Okay, so we'll start with direct current. Most of the currents that we use, like from batteries and those cells and so on, they are direct currents. And one feature of a direct current is that a direct current is a flow of charged particles. As a matter of fact, any electrical current is a flow of charged particles in whatever medium, whether it be in metals, whether it be in semiconductors, whether it be in electrolytes or wherever it is. It's a flow of charged particles. And a direct current is a flow of charged particles in a fixed direction due to an electric field which is also in a fixed direction. So here we have an electric field coming down, and these are the charged particles flowing. So these charged particles constitute an electric current. Okay? And that's a direct current because the charged particles are flowing in one direction. All right. In contrast, an alternating current, or use AC, is a flow of charged particles that change direction periodically due to an electric field which also changes direction periodically. So as the electric field changes direction, the charged particles also change direction. So an alternating current, the charged particles change direction. And so we'll demonstrate this. So we have the alternating current, the charged particles, as the field changes direction, the charged particles go up. The fields change directions to up, the charged particles go down, and so on, right? And so as the electric field changes direction, the charged particle move in a. And if you notice, and we can recall from the last class that we did, how, I'll just go back a little bit, all right, so here we notice that the field is down, but the charges are negative and the charges are moving opposite to the field. And try to remember from the last lesson that we did, we looked at forces of electric fields on charged particles. And we said that the negative charge will move in opposite direction to the electric field. All right, and so this is consistent with what we have done before. All right, so we looked at our alternating current. Now, an AC current can be represented by what is called a rotating phasor. Now, what a phasor is, it's a straight line having a definite direction and length, because we have various models to represent these phenomena that take place. All right, and so we use a rotating phasor in order to represent an alternating current. So as the objects, the charged particles change direction, they produce what is called an oscillatory motion. They move between two fixed positions. In a direct current, all the charged particles begin to drift through the conductor. But with an alternating current, as the electric field changes direction, the charged particles drift, and then they drift in the opposite direction. And so they perform oscillatory motion. And if you can recall in your mechanics, you would have done oscillatory motion in which a body moves between two fixed positions. And you can represent this motion with circular motion, because the projection of circular motion, it's projected onto oscillatory motion. And so a phasor is that type of oscillatory motion. And so let's look and see what we have here. So as the particles move, the phasor begins to go around. The phasor is going around in an anti-clockwise motion, up and down, and then up and then down. As it goes, the phasor begins to go around. And so the phasor is now what we are going to use to represent this alternating current. Or we'll represent the alternating current by the phasor, and we'll see how using this phasor we'll be able to come up with an equation for an alternating current. Okay, and so right now we are at the point where we're saying that an alternating current is a current which changes direction periodically because of a changing electric field. Whenever you switch on a light or whenever you switch on a device in the conductor, an electric field immediately appears, and that electric field causes the charged particles in that conductor to begin to move. Okay, and so that's in an alternating current, we have an alternating voltage which produces an alternating electric field which causes the charged particles to move in alternating directions. All right, and so we move on. So the phasor rotates through an angle theta equal to omega t in a time t from position 1 to position 2, where omega is the angular frequency of rotation. Do you remember from when you had in your mechanics, we said that the angular velocity is equal to the angular displacement divided by time. And so we can say that the angular displacement is the angular velocity times time. Okay? Well, in our phase, as the phasor goes around, the phase is describing an angle, and the phasor moves from position A to position B, and it goes through an angle omega t. Okay? It goes through an angle omega t. And this should look very familiar to you because you would have done it in mechanics. But we use slightly different terminologies. In mechanics, we said that this would be the angular velocity. If you notice, we use here angular frequency. And so it's the same thing. This angle here, theta, it moves through an angle theta, and that will be omega t. And omega, like in mechanics, is equal to 2 pi divided by the period of the rotation of the phasor. So if an object is going along in a circular path, then the period would be 2 pi divided by, the period would be t, and the angular velocity would be 2 pi divided by the period. Here we use angular frequency is 2 pi divided by the period of rotation of the phasor. Okay? All right, and so we have this diagram here. So I naught is the radius of the circle which the phasor is going around. The phasor describes, and it's the peak value. I naught corresponds to the peak value of the current. And I is the magnitude of the current at any time t. And so this dimension here represents the current. This dimension here represents the peak value of the current. And so if we look at this diagram, there is a triangle formed. All right? There is a triangle formed. There is a triangle formed here. Right? And this triangle is a right angle triangle because I is perpendicular to this horizontal here. This would be the hypotenuse, and this would be the side opposite. And so if we use trigonometry with that triangle, we'll see that we have that from the trigonometry that sine times omega t, sine of omega t, which is the angle, is equal to the side opposite over the hypotenuse, I over I naught. If we redistribute, we will see that we have that I is equal to I naught. I have A here, but this ought to be I naught. That's I is equal to I naught sine omega t. That represents an equation for, right? This equation represents the magnitude of an alternating current at time t. That's what it represents, the magnitude of an alternating current at time t. So this triangle here represents the at any time t. So we have an equation. I is equal to I naught sine omega t. And in order for an alternating current to be produced, there must be an alternating voltage. We can't have a current unless we have an EMF or a voltage to drive the current. You must have a potential difference in order for any current to take place. So for instance, a water current flowing down, water current comes from a high potential gravitational potential to a lower gravitational potential. If there is no difference in height, then the water doesn't flow. And in any kind of flow, wind, the flow of wind, high pressure area to a low pressure area, high elastic potential to low elastic potential. And so in the same way, you must have an alternating voltage in order to drive an alternating current. And so an alternating voltage has the same characteristic as an alternating current. And so if we want to have an equation for what an alternating voltage would be, it would be V is equal to V naught sine omega t. And we'll see how we would use these alternating currents and alternating voltages. Okay. Let's consider the phase at various positions in its rotation. The magnitude of the current is projected onto a current time axis at equal time intervals. All right, so we have current time axes at equal time intervals. And so let's see what happens here. So we have at this time interval, we're projecting where it is at these points here. So we're projecting at this point, we're projecting it here. At this point, we're projecting it, this one here, and this one here. So what we have seen, we have projected those points at equal time intervals on these axes. All right? And so what we see has happened is that with these projections of all of these at these positions here, when we graph it, if we draw a line through the points, we will see the line through the points is a sinusoidal curve. And that is not surprising because our equation tells us it's a sine relationship. Our equation says it's I is equal to I naught sine omega t. So we expect a sinusoidal relationship. And so here we see when we're using the phasor represents the current, and the phasor when projected onto axes, the movement of the phasor when projected onto axes represents a graphical representation of the current. Okay, and so here, this outcome corroborates what we get for our equation. All right, and so here now, we are at the point where we see we can represent an alternating current by an equation, and we can also represent an alternating current graphically. So what we will look to see now, if they must be related, because we can't get a graph unless we have an equation. If we have a graph, we have some form of equation that will represent the graph, or at least be able to model what it is on the graph. Okay, and so let's see the relationship between the equation that we got for the alternating current and this graphical sinusoidal relationship here. Okay. So here is an AC graph. This is what you would find on an oscilloscope. So this is an AC graph. And so we will look at some parameters, or these are some quantities that are related to an alternating current that we can determine from a graph. Okay? And so the first one, on the current or voltage time graph, this can either be a current time or a voltage time graph, because you remember we said that they have the same characteristic. If they are plotted on the same axes, they wouldn't have the same height, because you remember that voltage is equal to current times resistance, or current is equal to voltage time resistance. And so the voltage might be higher than the current. Okay? All right, so here, I naught represents the peak current from the middle line, from the x-axis up to the peak of any part of the thing. I naught is from here to here as well. Okay, that represents the peak current. And we have T, and we have two means of measuring T. T is the period. T is the time it takes for this alternating current to make one complete cycle, or the time it takes for the phasor to make one complete rotation, or the time it takes for a charged particle in the conductor to make one complete oscillation. They're all the same. Okay, so it's the time it takes for this graph for one complete cycle, time it takes for the phasor to make one complete rotation, or the time it takes for a charged particle in the current to make one complete oscillation. All the same. So T is the period, and it will be from alternate 0 points on the graph, or between two consecutive peaks. Okay, and either of them will give you what the period is. Okay, and so those are two quantities that are parameters of the alternating current. So we can speak of peak current, we can speak of period. And if we go back, again, if we go back to your mechanics, you know that frequency and period are related, and that is also from oscillations. The frequency is the reciprocal of the period. So frequency is equal to 1 over period, and vice versa. Period is equal to 1 over frequency, the inverse of frequency. Okay? So here we have period is equal to 1 over frequency. Okay? So the question might arise, what is frequency? So the frequency is the number of complete oscillations that are made in unit time, which is 1 second. How many how much ever oscillations are made in 1 second, that's the frequency. The period is the time it takes for one oscillation. Okay? All right. Now we're going to look at what is called the root mean square current. All right, the root mean square current. When you want to represent, oftentimes statistically and otherwise, when you want to represent something about a group of person, you talk about the average height or the average weight of something. The average, and the average gives you an estimate. It doesn't say everything about the individuals in that group, but it says something about if you say, well, the average height of a basketball team is 6'7". You know, is that really a lot of tall people, all right? And if you say the average height of the football team is 5'8", you know those are average height people. Okay, you can say something about the quantity or whatever it is by taking an average. And so the root mean square. But if you try to take the average of an alternating current, it will average out to 0. Let me show you. Reason being. All right, I'll go back a little bit. Reason being. All here is positive and all here is negative. So if I average out this positive and negative, they are identical, but one is positive. When you add them, you get 0. And if a positive, negative, positive, and if you keep going on, you get positive and negative. If you keep adding them, you will get 0. So to take just an average, it will be futile because the average of an alternating current will always be 0. So what is done, you take what is called the root mean square. And the root mean square means it's the mean of the squares of the current. It is different from the square of the mean. It's the mean of the squares of the currents. And let's see how that is done. The RMS current is used to represent the average current or voltage in an AC system. All right? And RMS means the root mean square and is the mean of the squares of the currents over a current or voltage cycle. So you take a cycle and you average all the currents over that cycle. So here is an example. Consider the intervals taken on a current or voltage time graph. So we take when the current, the quantity is 7 units, 10 units, 7 units, and we go right across a whole cycle. Okay? So we just took those intervals, and you take it at equal time intervals. All right? So we took those. So if we now go and the table below can be made, right? The values we took 7, 10, 7, 0, negative 7, negative 10, negative 7, and 0. All right? We can square all of those. 49, 100, 49, 0, 49, 10, 100, 49, 0. We know when we square a negative quantity, we get a positive. So we took the values, we found the squares. Now we're going to find the mean of the squares. We're going to find the mean or the average of the squares. So the sum, first of all, you find the sum of the squares, that's 396. And then you find the mean of the squares, you divide the sum by the amount, 1, 2, 3, 4, 5, 6, 7, 8. And when you divide 396 by 8, you get 49.5. That is the mean of the squares. But you want the root of the mean of the squares. So you'll take the square root of the mean of the squares. And so when we take the square root, you get 7.04. Okay, you get 7.04. So let's go further, and we'll see that the peak value divided by the RMS value, if we do that, we will get 10 divided by 7.04. Remember the peak value, if I go back just quickly, the peak value here was 10. at the peak there, 10 or negative 10, but it's 10 units tall. That's the peak value, okay, 10. So we'll divide the peak value by the RMS value, and you get 1.42, which is approximately root 2. Now, what would happen if we had taken more? We took 0, negative 7, 10, 7, 10, 7, 0. If we had taken 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and go right and take the values very close, this value here, 1.42 is quite close to root 2. Because if we round it off to one decimal position, root 2 is 1.41 and 1.42. If we round them off to the first decimal position, we'll get 1.4. But if we take more points over the cycle, it becomes closer and closer to root 2. Okay, this is just a quick example. And then, so if more intervals are used, then it can be shown that I0 over root 2 is equal to IRMS. The RMS value is equal to the peak value divided by root 2. RMS value is equal to the peak value, so we can represent this current. As a matter of fact, when you talk about your outlet, and we'll see a problem with it, your outlet is 110 volts. That 110 volts is the RMS value you're being told. They tell you the RMS value. Don't tell you the peak value. They tell you the RMS value. So we have 50 cycle, 110 volts. So that 110 volts, they're saying that is told is the RMS value. That is what is used now to represent either the current or the voltage. Okay, the RMS value. Of root mean square. All right. So the RMS value represents the direct current that dissipates the same power in a resistor. It is often called the equivalent DC. So RMS value is whatever the equivalent DC would dissipate, power in a resistor. How much ever power an equivalent, this equivalent DC will how much ever power the alternating current dissipates, the RMS value says that this DC current here would dissipate the same amount of energy in a resistor. And we call it the DC equivalent. Okay. Unless otherwise stated, the values quoted for the magnitude of AC currents or voltages are the RMS values. If they're going to say, if in any event, if they're going to use any other thing, any other quantity with regards to an AC current or the magnitude of an AC current, because you can have the peak voltage or current, you can have the peak-to-peak voltage or current, it will be clearly stated. But if you just say an alternating current of so, it means it's an RMS. If they want to say, they will say the peak-to-peak voltage of an AC current and so on. All right? So, let's look at some sample questions. So here we have an AC voltage graph. All right? And so for the AC voltage trace, you want to find first the peak. That ought to be V0. The V0, this is my error in preparing this. This ought to be V0, VRMS, T, and the equation. All right? There is big voltage here, and I have I0. I get 0 for that one there. All right. These ought to be V0. This is V0, VRMS, and then we look at the equation. All right? So V0 will be the peak voltage, which is any one of these peaks here would represent V0. Okay? And so here, V0, this is 5, 6, 7, 8, 5, 6, 7, 8, 9, wow. 5, 0, 1, 2, 3, 4. All right, it's about, again, this is about 6 volts, a little bit above 6 volts. because this is, each one of these is 1.25. That's about 6.25 volts, all right? Let's round it off to 6 volts. There, okay? And then IRMS, all right, the RMS value would be the peak value divided by root 2. And since we're using 6, it will be 6 divided by root 2, which is about 4.2 volts, all right? Or VRMS would be 6 divided by root 2, which is 4.2 volts. And then we have T, right? T would be between from 0 to alternate 0. And this one is at 20 milliseconds. This one is at 40 milliseconds. So it will be 40 minus 20. That would be 20 milliseconds. All right? And so in order to determine the equation now, we know the equation is of the form, 6 sine 100 pi t. All right? So we have t is equal to 20 milliseconds, and that would be 20 times 10 to the negative 3 seconds. F is equal 1 over t, and that would be equal to 1 over 20 times 10 to the negative 3. All right? And so the equation would become V is equal to 6 sine, and remember it's omega, which is 2 pi over 20 by 10 to the negative 3, and that will work out to be 100 t, pi t. Okay, so that's how we end up with that there. So it will be 6 sine 100 pi t. Okay, that would be in volts. Okay, all right. All right, so it says find the voltage at t equal 11.5 milliseconds. Now I want to emphasize what I have written here. Whenever you're using this equation, you must use the angles, the sine and the cosine, or whatever you use, it must use the radian measure, because omega is measured in radians. So omega t is a radian measure. So you'll have to move your calculator from the degree mode to the radian mode. If you use your calculator in the degree mode to calculate the sine of any angle or the sine of anything, in this particular case here, you will get the incorrect answer. You must move your calculator to radian mode because the omega t is in radians. You must be put in radian mode to find the sine. Okay, and so we'll just substitute in order to find that. We'll find that V is 6 sine 100 pi times, remember 11.5 milliseconds is 11.5 over 1,000, which is 0.0115. And so that will give 6. And when you find sine of 1, you'll get sine of this, 100 pi. Ooh. All right, let me just take off a piece here. We'll get sine of, you'll get 6 sine of 100 pi, that would be 1.15 times 3.142. All right? So when you multiply 1.15 by 3.142, you'll find the sine of that. And remember again, very important, extremely important, that you put your calculator in the radian mode for this. And when you work that out, you'll get 0.4 and you'll get the current or the voltage being 2.7 volts. Okay? So let's go on to another, the same sample question continued. It said, draw the equivalent DC of the alternating voltage. So what they're asking us is to draw a line to represent the RMS. Remember, DC doesn't change direction, so a DC would be a straight line across, and it will have the same magnitude as the RMS voltage. Okay, and the RMS voltage is 4.2 volts. And so when we draw our line, this here would represent the DC equivalent of this alternating voltage. Okay? If DC equivalent is the same as the RMS voltage. Okay. It says another sample question. Domestic electrical outlets in Jamaica are rated at 110 volts with a frequency of 50 hertz. Write down the equation for a domestic outlet. So, we know that the VRMS, remember when we said 110 volts, it means VRMS. VRMS of 110 volts. And so V0, the peak voltage, would be VRMS times 0.2, because you remember VRMS is V0 over root 2, we cross multiply, we'll get that, and we get that the V0 is 155.6 volts. And so omega is 2 pi divided by the period, or 2 pi times frequency, and it says the frequency is 50 hertz. We have 50 cycles. And then, so we multiply the 2 pi by 50 and we get 100 pi. Okay? And so the equation would be V equal 155.6 sine 100 pi t. That would be an equation for the electrical output of an electrical outlet here in Jamaica. Okay. So let's go back. We said that alternating current is a current that changes direction periodically because of an alternating electric field. And that electric field will be set up by some potential difference existing across. And then that is in difference to a direct current in which the current flows in one direction. And because of its periodicity, we can set up a phasor which represents the alternating current, because the alternating current moves periodically, and so we set up a phasor. And we can use that phasor in order to write an equation for the alternating current. And using that equation, we can find many parameters with regards to an alternating current. And also, we can use it to calculate quantities that are related to an alternating current. We also saw that we can use the graph to find some parameters for the alternating current. And we introduced a new term called the RMS value of the alternating current or voltage, and this is what we said is the direct current equivalent of an alternating current, and it is equal to the peak voltage or current divided by the square root of 2. Now, one important thing I must mention again, that when we are using the equation for an alternating current, we must always use our calculator in the radian mode. We've come to the end of our classes for today. For a repeat of all 3 sessions, tune in later to JNNN at 4 p.m. or you can subscribe to onespotmedia.com to catch up on all you've missed. Class time continues tomorrow with CSEC Home Economics and Agricultural Science and Cape Caribbean Studies. Until then, bear this in mind. Without labor, nothing prospers. So if you put in the work, you will reap the reward. Goodbye and keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.